become a smart contract developer, create your own applications that run on blockchains? Well, one of the first things you're going to have to understand is smart contract, how they work, what they are, and how to use them. So in this series, I'm going to assume that you do have some sort of programming language experience, but you don't have to have a lot. You just have to understand the basics, what variables are, and conditional loops, and just the basic fundamentals of programming. If you don't have that, you might want to maybe watch a video on that, maybe just a beginner's course for JavaScript. Just understand the syntax and you'll be able to understand everything I'm talking about, basically. But smart contracts are contracts that run on the blockchain. In this series, I'm going to bring you from beginner to intermediate level. So by the time you're done watching these videos, you should be able to develop your own smart contracts and deploy them to whatever blockchain you would like. So what is a smart contract? So a smart contract is a self-executing piece of code that runs on a blockchain. What that basically means is that there's no single machine that is hosting this code, and you can't turn it off. So once the code is out there, anyone can interact with the code and it's going to execute. Once you give it a particular input, depending on how it is programmed, it will run some sort of process or give you some sort of response. So the code is also immutable, meaning once the code is added to the blockchain, the code itself cannot change. It's there for the life of the blockchain. It's also decentralized, so there's no single point of failure. The code is not living in one single place. It's spread out across the entire blockchain, so that makes it decentralized. So smart contracts can also interact with other smart contracts. So you can have one smart contract talking to another smart contract, or getting some value from that smart contract and going off and interacting with another smart contract. So they're very configurable, and there's a lot that can be accomplished with the fact that they can communicate with each other. So how are they used? There are a lot of use cases for smart contracts. One way is to automate processes. So that is very good for businesses. There are a lot of little processes that people are hired for that can easily be automated by programs. In the case of a smart contract, no, because the fact that the code is immutable, decentralized, and a number of other features gives this ability to automate processes even more use cases and makes it even more powerful. It can also facilitate transactions. So there are these things called DEXs, which stand for decentralized exchange. It's a set of smart contracts that allows you to buy and sell cryptocurrencies, other tokens on the blockchain, smart contracts. So that's what it means by facilitating transactions. It can also assist in identity management. So because smart contracts are built on top of a blockchain, and blockchains are secured using something called cryptography, which is a mathematical way of hiding a secret, you can guarantee that a particular thing was done at a particular point in time, and you can prove that with cryptography. So with those features, makes it very ideal for identity management. Now, there's a number of different ways to implement this, but it's a very powerful use case of smart contracts. It's also used to ensure compliance. So also in a lot of businesses, there are very strict compliance rules that have to be adhered to. And if you can use a smart contract to ensure compliance, it guarantees compliance even to a greater level, because if humans are the ones ensuring compliance, there is a lot of room for error. Now with a smart contract, it makes that much less likely. Once a smart contract is coded properly and tested properly, it's very hard to violate compliance using smart contracts. So that's just a few examples of how they're used. There are many more ways that these can be used, even ways that have not even been thought of as yet. But these are just a few. So languages used to create smart contracts. So there are a lot of languages that are used. This is just a short condensed list. So you have Solidity, Viper, C++, Rust, JavaScript, Java. So in this series, we're going to be focused on Solidity, which is the most popular smart contract language. And I believe it might be the only one on this list that is exclusively for smart contracts. I think Viper might be, but I don't know exactly the facts on that. But I believe Solidity might also be the youngest language on this list. But either way, this is just a short condensed list of what is used to develop smart contracts. If you can Google and you'll find a much more extensive list. So yeah, so let's touch on data types really quickly. So there are two types of data types in Solidity. You have value types and you have reference types. So value types refers to Booleans. So Booleans are basically a variable that has true or false. It can only return either true or false. If you don't fully understand programming, I will be going over that in a future video if you don't understand this programming concept, but it's a basic programming concept. Integers, these represent numbers. So an integer or a uint, which stands for unsigned integer, is any number from 0 all the way to infinity. But in the case of Solidity, there is no infinity. The number actually stops at 2 to the 256 minus 1 power. So a uint will go from 0 to 2 to the 256 minus 1, which is a very large number. For an integer, which is not unsigned, so that you have to include all of the negative numbers, it goes from negative 2 to the 256 minus 1 all the way up past 0, all the way to 2 to the 256 minus 1. Very large numbers. So those are value types. And then you have reference types, which basically are different data types as it relates to memory and storage. So quick rundown, structs are a set of different variables that are placed at a certain point on the blockchain, a certain memory slot on the blockchain. And in order to find a specific structure, you have to give it like an ID or something, and then you'll be able to access that memory. Arrays is a set of values, usually it's of one type, so it could be numbers, strings, whatever. Mappings are a little bit more complex. So mappings, it's in most cases, not all cases, a mapping is a value type that points to a reference type, right? So we'll get more detail into that, but this is just a quick introduction as to what I will be teaching in this course. So go ahead, like the video, subscribe to the channel, comment, ask me questions. I'll be happy to respond, and stay tuned for the next video.